Next up, we're going to look at an application of dividing polynomials. So let's say you have a rectangular object and you know that the length is a certain number plus 4, but you do not know what the width and height could be. You know one other thing, that the height is greater than the width. You also know this equation for volume in terms of the same variable x. First up, let's note that volume is length times width times height. So if I want to get width times height by itself, I need to take volume and divide it by length. Alright, this is when we set up our polynomial division. I take my polynomial that represents my volume, and I divide that by my length expression, x plus 4. Alright, now to make sure we can see. Okay, so first I can say x times x squared gives me an x cubed. So I do my polynomial division. Then x times negative 4x gives me negative 4x squared. And last up, I have a positive 3. That will give me no remainder. Great. So now what I found is that width times height is x squared minus 4x plus 3. My last step is to get width and height by itself. That means I need to factor my binomial. Alright, so when I factor x squared minus 4x plus 3, I get x minus 3 times x minus 1. Now, I already knew that height is greater than width, so now I know height must be x minus 1, and width must be x minus 3, noting that length is x plus 4. How could you check that? You could multiply length times width times height and make sure we get our original volume. So I would take x minus 1, multiply x minus 3, and x plus 4 to make sure I get my final volume. Let's do that. Alright, I'm going to multiply x minus 1, x minus 3, x plus 4. First up, I get x squared. Alright, then I multiply these last two, get x cubed. You can be doing this on your own. Okay, let's combine our like terms here. So, those cancel out. Awesome. So we get back to our original volume.